Dear students, I am JMA. Hope you all are fit and fine at home. We know that due to the corona pandemic, the whole country has locked down itself. Due to this, colleges are shut down, so we can't be able to take classes in the regular mode. So we plan to conduct classes with online mode. You must take advantage of this opportunity.
The units and the papers allotted to me is applied electronics, third, fourth and fifth unit, skilled based subject, first and second unit, atomic physics, second unit. We start with unit 4 of applied electronics. The unit 4 is a multi-vibrators and operational amplifiers. In this unit, the first topic is RC time circuits. What is R? R is the resistance. C is the capacitance. This circuit contains the resistance and capacitance. What is RC time circuits? It is the electrical and electronic circuit which produces time delay. The time delay is between the input and output terminals. That is, the signal is applied at the input and it is delayed by some time and it is appear across the output. The signal is generally the AC voltage or DC voltage or any wave forms are applied. This circuit consists of the voltage source Vs, that is a DC voltage battery, and a switch, a resistor, and a capacitor. Before going to discuss this circuit, we must know what is a resistor. It is a passive electrical and electronic device. It has two leads. It used to resist the current. They are used to reduce the current and also used to regulate the voltage in some electronic circuits. Physically, the resistor is appear like this. The electronic symbol for the resistor is like this. And another component used in this circuit is capacitor. It is two-terminal electrical device used to store the charges in the electrical circuit. Physically, it appears like this, and its electronic symbol is for the fixed capacitor. This is a polarized capacitor. It has two terminals. One is positive, negative. It is a variable capacitor. When an increase in DC voltage is applied to a capacitor through the resistor that is connected in series with the capacitor, it forms the RC circuit. The capacitor charges gradually through this resistor until the voltage across reaches, that is, the voltage across the capacitor equals to the source voltage. This process is called charging. When the voltage is reduced, the capacitor begins to discharge in the opposite direction. So during the charging, the plus is here, minus is goes there. While discharging, the negative potential comes from here and positive potential comes from here. The charging and discharging of a capacitor energy is never instant, but it takes some time. The time taken for a capacitor to charging and discharging is to its maximum supply value is known as the time constant. The time constant depends upon the value of resistance and the value of capacitor. The RC circuit is used in camera flashes, pacemakers, time circuits, and etc. The RC signal filters the signals by blocking some frequencies, it allowing other to pass through it. From this area, we can expect these three questions. Next we go to wave shaping circuits, that is clipping and clamping. The wave shaping circuits are electronic circuit. They used to change the time varying electrical voltage or input waveform using the passive and active components like transistors, ICs, and resistors, capacitors, inductors. What is the use of these wave shaping circuits? The wave shaping circuit is used to limit the voltage level of the waveform and to hold the waveform to a particular DC level and suppressing all other voltage levels. First we will see what is clipper. A clipper is an electronic circuit which clips or removes a portion of the waveform, the signal waveform. The clipper consists of the diodes, resistors, and power supplies. So a clipper which removes a portion of positive half cycle of the input waveform is called as positive clipper. The clipper circuit that removes the negative half cycle of the input waveform is called as negative clipper. Okay, what is series clipper? Before going to series clipper, we will see what is diode. A diode is a two-terminal semiconductor device which allows the current in one direction. These devices are used to protect the circuit by limiting the voltage, and it is used to convert the alternating current into direct current. So it also called as a rectifier. The diode is also called as rectifier. The silicon and germanium semiconductors are used to make these diodes. Here, it is a p-type semiconductor material region. It is a n-type semiconductor material region. Both are combined to form a diode. It has two electrodes. One is anode, positive, and another is cathode. It is the electronic symbol for the diode. Physically, it appears like this. Okay. Now, we go to series clipper. The series clipper are again classified into two types. One is negative clipper, another is positive clipper. First, we see series negative clipper. The series negative clipper is shown here. It consists of a PN junction diode, a resistor, and a waveform generator. This generates sine wave, square wave signals. When the AC signal is applied here, it is passing through this diode. Now, the diode is connected in the forward bias. What is forward bias? When the positive potential, see here, it is a biasing voltage plus the positive potential is applied to P region. It is called forward bias. And the cathode is connected with a negative potential. This type of biasing is known as forward bias. During the forward bias, the diode conducts such that the entire positive half cycle, see here this one, this positive half cycle, appears across the resistor, this one, which is connected parallel. During the negative half cycle, the diode is reverse bias. What is reverse bias? A p-type material region, that is the anode, is given with negative potential. And the n-type semiconductor region is given a positive potential. This type of biasing is known as reverse bias. During this reverse bias, no output appears across the resistor so that it allows only the positive cycle and it cuts the negative off cycle of the input waveform. Therefore, it is called as series negative clipper. So it removes the negative portion. In this, during positive off cycle, when the diode is in the forward bias, the output voltage V output is equal to the input voltage minus diode voltage. During the negative off cycle, so the diode is in reverse bias, so there is no output voltage, so V output is equal to 0 volts. Now is go to series positive clipper. See here, this circuit also consists of a waveform generator, that is a voltage source, the diode and the resistor. Here, the diode is connected in reverse bias. You know very well what is reverse bias. When the waveform is applied here, it passing through the diodes. When the positive off cycle is coming here, it acts as reverse bias. So it never allows the waveform or voltage here. So this portion gets cut off. And the next off cycle here, the diode now acts as forward bias. Why? It is negative. This portion is a negative. So the diode, here it is also negative, here positive. So the negative portion is moving here. It is negative, so negative and negative, so it is a forward bias. So it allows the negative portion only, and it is appears across the resistor that is shown in this diagram. While in the forward bias, it completely cuts the waveform. Okay. Now, during the positive off cycle, output voltage is 0. During the negative off cycle, the V output is V in plus the diode voltage. Okay. What is the application of clippers? They used to generate the new waveforms or shape the waveforms, and it is commonly used in the power supplies and used to separate synchronizing signals and used in FM transmitters, etc. Next we go to clampers. It is an electronic circuit that is used to shift the entire signal or to down the output signal peaks to a desired level. So actually it combines the DC voltage with AC waveform. In this, the diode clampers, the clampers are also be referred as DC restorers. In clamping circuits are designed to shift the input waveform either above or below the DC reference level without changing any waveform shape. This shifting of waveform results in the change in DC average voltage of the input waveform. The level of peaks in the signal can be shifted using the clamper circuits. The clamper circuits are classified into two types. One is positive clamper and the negative clamper. What is positive clamper? This circuit shifts the input waveform, that is input voltage, in positive direction. That is, it adds the positive DC voltage. As a result, the input waveform lies above a DC reference range when it is come to the output. Okay, what is negative clamper? This type of clamping circuit shifts the input waveform in a negative direction. As the result, the waveform lies below a DC reference voltage. So the direction of the diode in the clamping circuit determines the type of the clamper. The operation of clamping circuit is based on the switching time constants of the capacitor. The capacitor in the circuit charges through the diode and discharges through the load resistor. This time delay decides the shifting. The types of clamper circuits. First we will see the negative clamper. What is negative clamper? A negative clamper circuit consists of a diode connected parallel with the load resistor. Here this is load resistor. This is waveform generator. This is capacitor. We know very well that what is diode, how it is works, what is the forward bias, what is the reverse bias. Okay. Now, in this circuit, the input waveform, that is a sine wave, is given here. This sine wave first initially charged by the capacitor. When it is fully charged, that is during the positive half cycle, the diode is forward bias and the diode conducts the capacitor charges very quickly to its peak level using this input waveform. During the negative half cycle of the input, the diode will be reversed bias. So here. And the diode will not conduct. The output voltage will be equal to the sum of applied input voltage and the charge stored in the capacitor during reverse bias. So the output waveform is same as in the input waveform, but shifted below 0 volts. See here, it is 0 level. Initially, the waveform was here. After entering to the capacitor, it charges up and then it adds with the voltage. The output is shifted below. This is the 0 level. Shifted below to this voltage minus V. So initially it was here, now it is shifted down. This type of clamper is known as negative clamper. Now we will see the positive clamper. What is positive clamper? The circuit of a positive clamper is similar to the negative clamper, but the direction of diode is inverted in such a way that the cathode of the diode is connected to the capacitor. During the positive half cycle, see here, this is the voltage waveform generator. This is a capacitor. Now the direction of the diode has changed and it is the output load resistor. During the positive half cycle, the waveform generator generates the AC waveform. It is the positive cycle. It is a negative cycle. During the positive half cycle, the output voltage of the circuit will be the sum of applied input voltage and the charge stored here. Charge stored in the capacitor. During the negative half cycle, the diode starts to conduct and charges the capacitor very quickly to its maximum value. So both the voltages are adds up. So it shifted out waveform. They shifted from this zero level. See here it is zero level to some positive DC level. This area is positive voltage. They shifted to some positive area. So actually it was here. Now it is shifted. So clamped. So this type of clamper is known as positive clamper. So okay, what are the application of clampers? The clampers are frequently used to remove the distortions, noise present in the circuits. And it is also used to improving the reverse recovery times. And it is used in voltage doublers for modeling on the existing waveform to require shape and range. The clampers are widely used in test equipments and the sonar systems. Okay, we have covered what is clamper, what is clipper, what is RC network. Now we will see some problems from this area. For the given input waveform to the given circuit, what is the minimum value of output form? See here, this circuit is nothing but a positive clamper circuit. Additionally, a voltage source is connected here. So how will you solve? The circuit is a parallel clipper. When the input is less than 4 volts, here the diode is forward bias, and thus the output voltage is also forward 4 volts. Why? So the 4 volts is given here. 4 volt battery is connected here. So it allows the voltage equivalent to this volt. When the input increases above 4 volt, the diode acts as a reverse bias. A positive voltage is coming here. So negative voltage goes there. So here plus the diode is now act as a reverse bias. So the output is equal to the input. So whatever may be the input, it allows only 4 volts, which is equal here. So it gives the minimum output voltage 4. Okay, we will go to the next question. For the given circuit, the minimum peak value of the output waveform, the input waveform is 10 volt square wave with switching time of 1 second. Assume that the input switches between plus volt to minus volt DC level. Okay. See here a capacitor is plus, here minus. So it is connected in forward bias. The diode is connected in forward bias. It is the load resistor. For the positive off of the input, the diode is on the on state and it acts as a short circuit so that the output voltage appears is 0 volts. During the negative off cycle of the square wave, the resistor receives the voltage input both from the source and the capacitor, which charged during the positive off of the input. So it gives, already there was a 10 volts, minus 10 volts, and again it gives another minus 10 volts. So we will have totally minus 20 volts. Okay. So I have given the questions belonging to this area. Your homework is to prepare the questions and answer in your notebook.
Dear students, what this video till end, I purposely made some mistakes in this video. Identify and report me. It will help me to maintain your attendance. Do the homework daily, that is, prepare answers for the questions from this video and send the scanned copy to me on every fifth hour of day order 1 to evaluate your response and to award internal marks.